Sorry guys, I was having a hard time setting up my phone on my pile of books on my desk. Got quite the setup going on here. We're going to continue 9.4. This is part 2. Still talking about arithmetic series, but now we're going to add in summation notation. Okay, so this symbol here is a Greek letter, and it's called sigma, and it means sum. So anytime you see this, you're going to be adding. We're going to be using limits. So we'll have the least and the greatest values of n for the series. And we're going to write series and summation notation. Okay, so your limits are here. We've got sigma, so that means we'll be doing a sum. And at the bottom, it will be your first n. And at the top, we're going to write the number of the last n. And then off to the side in parentheses, we're going to have the simplified arithmetic sequence formula. Okay, so let's just go do an example and it'll make more sense. In example 4, we're going to write the arithmetic series and summation notation. So here's the series that we're given. We're starting with a 7, and then it's adding 11 plus 15, ... The pattern continues until we get to our last term, which is 207. So in order for us to write this arithmetic series and summation notation, the first thing I need to do is figure out how many terms do we actually have in this series. And to find n, we're going to use the arithmetic sequence formula from 9.2. So I know the value of my last term in the series, that's the 207. So that's what I'm putting here. And the value of the first term in the series is 7, so that's what I'm going to substitute for a sub 1. We're looking for n. And d, the common difference, is 4, because every time to move from position to position, we're adding 4. We're going to get rid of the parentheses by distributing. So 4 times n gives us 4n, and 4 times negative 1 gives us that negative 4. Now I'm going to combine like terms. The 7 minus 4 leaves us with 3, plus the 4n. And we'll come back to this pink part in a minute, so for right now you can ignore that. I want to get n by itself, so I'll subtract 3 from both sides. And once I do that, I have 204 on the left is equal to 4n. So time to divide by 4. And that gives us n is 51. Okay, so if we were to write out all of the terms in this series, when we got to 207, we would have 51 terms. Okay, so to write this in summation notation, we'll have our sigma, and we're starting with our first term, so at the bottom we'll have n is equal to 1, and we're going to the 51st term. So however many terms you have, if we're starting with 1, your n would go on top. So 1 to 51. And then here is your simplified arithmetic sequence formula. Okay, so that's the pink part that I was talking about. Normally it's going to be written that you have your variable term first, plus your constant. So I just switched the order here. Okay. 4n plus your constant would be your simplified arithmetic sequence formula. So when you're using it here, after you distribute to get rid of the parentheses, and after you combine like terms, once you get to your linear term and the constant, that's what goes here. Okay, so let's do another example. Example 5. What is the sum of the series written in summation notation? Okay, so this time they're giving us the series written in summation notation. It's telling me I want to add from my first term up until the 27th term. And here is my arithmetic sequence formula. Okay, so in order for us to find the sum, I'm going to use our formula from Monday. the sum of our terms would be equal to the number of terms divided by 2, and then in parentheses we'll have the value of the first term plus the value of the last term in our series. Okay, so to find the sum S sub n here, we're going to need 3 things. We need to know n, the number of terms, the value of the first term, and the value of the last term. Okay. And we do know how many terms we're dealing with because I'm adding from the first term to the 27th term, so that's 27 terms, n is 27. I can solve for the value of the first term by substituting 1 for n and then simplifying. Okay, so we're using this arithmetic sequence formula, and I'm substituting 1 for n and simplifying. So the -2 times 1 gives us -2, and then we'll add 1. So the value of the first term in this series is -1. And you can do the same thing for the 27th term. So to find the value of the 27th term, which is the last term in our series, we're going to use this formula right here, the -2n plus 1. And for n, we'd be substituting 27. -2 times 27 gives me the -54, plus 1 is -53. So the value of the 27th term in the series is -53. Okay, so I wrote out in words what we did there. We used the simplified arithmetic sequence formula. Okay, so that's this pink part matches up with this pink part. We use that to find the value of the first term, which is a sub 1. And then we used the simplified arithmetic sequence formula again to find the value of the 27th term, a sub 27. Okay, so once you have those 3 pieces, the n, the first term, and the last term, now you're ready to use your series formula. So we can find the sum by using this formula. I know I have 27 terms, so we're looking for the sum of the 27 terms, which is equal to, I'm substituting 27 for n over 2. And we found the value of the first term was -1, and the value of our 27th term was -53. When we divide 27 by 2, we get the 13.5. And here we can add -1 and -53 to get -54. Multiply to get -729. So the sum of our series, if I was to add the 27 terms, we would end up with -729. So that's it for 9.4 part 2. You have a Math Excel assignment. Please email me if you have any questions. And this is due Sunday night. Have a great day.